Hi guys! Happy Tuesday! Today's lesson is on 9.2.2 and it actually is about cross sections, but we're going to start by kind of bringing back what we talked about yesterday in terms of slices versus layers, and then we're going to get into cross sections. So yesterday when we asked you to look at the difference between slices and layers, the big idea was the fact that we wanted you to be able to see that even if I'm talking about the layers, I also have another way to look at something, which is by the slice. The important thing about slices, like in the cookies up here, is the fact that when I make a slice, I get the same thing all the way through. If I look at these Oreo cookies and I imagine I had a knife, if I went and I cut straight down the front face of this, I would get a layer, I would get these layers that would kind of look like the cake. So in order to get different layers versus slices, I might have to do some different types of cutting or when I'm putting my cut through my object, I'm going to cut either vertically or horizontally. So we're going to have to pay attention to that as we're working through here. When we were talking yesterday, we were looking at the volume and the surface area. So first, when I look at these two figures, if I look at the volume of the first figure, in order to figure out how many blocks fit in it, I'm going to find the area of the base, multiply it by the height, or I also could just take 5 times 6 times 4 and I get 120 inches cubed. That's how many cubes fit in this figure. In my other figure, I have the area of my base times my height, or in other words, 5 times 8 times 3, which also is 120 centimeters cubed. These two figures have the exact same volume, meaning they can fit the same amount of blocks. Surface area, on the other hand, is going to be a little bit different. The area of each of their faces, as I'm figuring them out, I'm going to get a different surface area for the two shapes. This first figure, I have two sides that are going to have an area of 30, which is going to be the back side 5 times 6 and the front side 5 times 6. I'm going to have two sides that are going to have an area of 24, so I have 4 times 6 for the left and 4 times 6 over here for the right. And I have two faces that are 5 times 4 for 20, so top and bottom. So I have a surface area of 148 inches squared. What that means is that's how much wrapping paper I would need to fully cover that box. Now for the other figure, I'm actually going to need a little bit more. I have 158 inches squared. When I look at this and I think about the layers, if I think about how many layers, all of my layers, the important thing is there 1-inch layers in my first one. I have 5 1-inch layers going back. Or I could think about I have 6 1-inch layers going up. So if I think about, this as slices, if I slice down the front, I'm going to be able to do that 5 times for each 1-inch layer. On this one, I have 5 1-centimeter slices. So if I slice down the front here, I'm going to have 5 1-centimeter slices and 8 1-centimeter layers going up. Now, when I'm talking about a rectangular prism, slices versus layers, it doesn't really matter because I can use either to decide that that's going to be my base and I'm going to find the area of my base. These figures here, if I look at the two figures, if I look at the volume, I have 4 times 5 times 10 or 200 meters cubed. This one, I have 10 times 2 times 10, 200 meters cubed. They look very different though. The surface area, top one has a surface area of 220 meters squared. Bottom one is going to have a surface area of 280 centimeters squared. Slices and layers is going to come in handy today. But the big thing is I want to make sure when I'm thinking about slices or layers, today I want you to think about what's going to happen depending on how I'm slicing this. So into cross sections. When we talk about a cross section, it is when I take a 3-dimensional solid and I cut it. So kind of think, I don't know if you remember Fruit Ninja, but kind of think you're going to Fruit Ninja these different types of solids. We have vertical slices, meaning we cut up and down. We have an angled slice, which means it's not going to go up and down or horizontal. It's going to kind of go at an angle, and then we have that horizontal slice. Depending on the type of slice you have, you could get a different figure.
Math Shorts. Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
Seventh graders, there's going to be a link that I want you guys to go check out in GeoGebra. And this link is going to let you kind of play around with different types of figures to figure out what they're going to look like. So in this first one, we can change where we cut through it by looking at the height, and we can go up or down. My computer's coming along here. So we can go up or we could go down. We could also rotate how our cut is. So instead of having a horizontal cut, we could rotate and have a cut through at a diagonal, or we could make a straight vertical cut. Now, on this one, you can actually look and see what kind of shape do you get. In this one, with a vertical cut through a rectangular prism, we actually have a rectangular shape. Part of your homework tonight is going to be looking at different cross sections. So you can use GeoGebra to help you out. So on this first part of your homework, you have to look at what a cone, if you have a cross section at the very top. So when you're looking in here, let's look at sections of cones. Now we want to make sure that we're towards the top. So if I shimmy the height up a little bit, now I can look at it and see it's a circle. I wonder what would happen if I moved it up or down. It looks like the circle is just getting bigger or smaller. So then in our homework, identify the shape that the slice with the blue and the orange, well, you can say it created a circle. Oops. And then what was the direction of the slice? Well, this slice direction would have been horizontal. And then will repeated parallel slices of the same direction result in identical shaped pieces. So what that means is when I'm talking about parallel, I mean I'm going to slice as in layers. Now, if I slice in layers, so here I'm slicing in layers, am I getting the exact same shape? Well, every time I'm getting a circle, but my circle is changing sizes. So I probably would want to write that down and explain that. So will the repeated parallel slices in the same direction result in identical shaped pieces? Not exactly. The shape will remain a circle, but it will get bigger or smaller depending on where the slice is located on the original. Feel free to use my exact same words when you go to your paper. Seventh graders, here's another way you can look at it. When I'm looking at my slices, I'm cutting it in half and I'm looking to see what is created. Most often, we're going to look at vertical and horizontal slices. but it's also important to take into consideration what might happen if I have that diagonal slice. When you're working today, if you have questions, remember, let me know. I'm available in email, Google Chat, or we can set up a Google Meet. I hope you guys have a great day, and I'll talk to you soon. Bye.